Hello AP Stats. What I wanted to do is make this video today for our remote learning so that you'll be able to come in and kind of hit the ground running come Thursday and Friday of this week because we're not going to have as much time as sometimes we normally do in class to go through this material. So let me show you what questions I'm going to be working on so you can follow along. So I'm just in section 6.2, the exercises. I'm going to take a look at question 54 first. So this idea of we have a distribution of scores among women with a mean of 120 and a standard deviation of 28, and scores among men 105 and 35. You select a single male student and a single female student. Find the mean and standard deviation of the difference. So we're going to start by setting that up, the mean and standard deviation of the difference. So here's what we know for the female students. The mean was 105 and nope, I'm sorry. For the female students, let me look at the book I got here. The mean was 120 and the standard deviation was 28. 120 and 28. For the male students, mean was 105, standard deviation was 35, and we need the mean and standard deviation of the difference. So what I'm going to be doing is finding the mean of F minus M. Means play nice. They do exactly what we tell them to do. So in this case, it's just going to be the difference, 120 minus 105, or 15 points. That's the mean difference. The standard deviation, as we talked about last week, you have two independent random variables here. So their variances are always going to add. It doesn't matter that I'm subtracting because the female scores have their own variability plus the additional variability from the males. So this would be the variance of the females plus the variance of the males. Add those up, take the square root to get the standard deviation. And this is about 44.8 points. So as far as interpretations go, I'm not going to write them out. I'm just going to verbalize them. For the mean difference, it would be if you were to repeatedly select a male and a female student, the difference in their scores would be about 15 points on average. So if we repeatedly select a male and a female student, the difference in their scores on average is about 15 points. The standard deviation would be the difference in scores will typically vary by about 44.8 points from the mean. Part B, it just says, can we calculate a probability? We can't. We don't know if these distributions are approximately normal or not, so that's not something that we're going to be able to do. So let me take a look at another question here from the section. Oh, if you want a master class, which I was looking at maybe getting, check that out. And now I actually closed the window for 56, so this is really annoying. Next question I wanted to take a look at was question 60 here. So you have the design of an electronic circuit for a toaster calls for a 100 ohm resistor and a 250 ohm resistor. So the resistance of the 100 ohm resistor has a mean of 100 and a standard deviation of 25. So mean of 100, standard deviation of 25. And the 250, 2.5, not 25. And the 250 ohm has a mean of 250 and a standard deviation of 2.8. Now we want the distribution of the total resistance, and then the probability it's between 345 and 355. Now you'll notice they said they are both normally distributed. So that's going to be extremely important. That's going to allow us to use a normal distribution for our density curve and calculate these probabilities. So in this case, the total amount is going to be the sum. So it's going to be the mean, if I call this x and this random variable y, the mean of the 100 ohm and the 250 ohm resistor. So the total mean would be 350 ohms. And the standard deviation of the total, I'm going to add the variances. So the 2.5 squared plus the 2.8 squared. And that's going to give me about 3.75 ohms. Okay, then I want to know what's the probability it's between 345 and 355. So now I have a normal distribution with a mean of 350 a standard deviation of 3.75 approximately, what I would do is calculate a couple of z-scores. I'm not going to go through this whole process. There's the mean. Here's 355. Here's 345. I need the area between 345 and 355. So I'd get a z-score for 345. That would end up being negative. The z-score for 355 would end up being positive. And then I would do normal CDF from that negative z-score to the positive z-score with the mean of 0 and 1, because I'm using the standard normal distribution. And this would be my answer, that area under the curve. It ends up being about 0.817, depending on rounding, if you do go through this. Okay, so let's take a look at another one. For question 62, so we're talking about toothpaste. He has a new tube of 0.85 ounces. And he's going to, each time he uses toothpaste, he's going to squeeze out about an average of 0.13 ounces with a standard deviation of 0.02. If he brushes his teeth 6 times, what's the probability he will use all of the toothpaste in the tube? So very similar to the last question, we have a continuous random variable here. We have a mean of 0.13 and a standard deviation of 0.02. But the reason I want to show this question is it's important that you recognize, so we have some random variable, the amount of toothpaste being used has a mean of 0.13, standard deviation of 0.02, and I believe they said it's approximately normal. He's going to use the toothpaste 6 times. So I need to really think about, is this 6 times x, or is this x1, x2 plus x6? Well, each time he squeezes toothpaste out of the tube, it's independent of the previous one, so this is not correct. That would be just using the toothpaste tube once and rescaling it by 6. So I'm really looking at having 6 independent random variables. So really, I need the mean of x1 plus x2 plus x6. Means play nice. They do exactly what you tell them to do, so I'm really just adding up the mean 6 times. So there's 6 of these. 6 times the 0.13 is going to be 0.78 ounces. That's the mean. Oh, that's off the screen. 0.78 ounces. The standard deviation, when I sum these up, I'm going to add the variances. So I'm really adding 0.02 squared plus 0.02 squared 6 times. So I really have the square root of 6 times 0.02 squared. That ends up giving me a standard deviation of 0.049 ounces. Now, because the distribution was normally distributed, it doesn't matter if I add, rescale, subtract, the shape does not change. So the shape of this distribution is approximately normal. The mean is 0.78. The standard deviation is 0.049. And they wanted to know what's the probability that he will use all of the toothpaste in the tube. So in this case, there was 0.85 ounces in the tube. There's my mean. There's 0.85. I'm going to calculate a z-score. I'm going to use normal CDF to get the area under the curve. I'll run through this one since I didn't show it in the last one. 0.85 minus 0.78 divided by 0.049. So the z-score is 1.43. I would do normal CDF from the 1.43 to infinity, with 0 and 1 as my mean and standard deviation. And this probability ends up being about 0.077. So there's a little less than an 8% chance that he's going to use all of the toothpaste in his tube. So I hope that this was informative, and then when you come into class on Thursday and Friday, we can hit the ground running as far as going through and working through these types of questions. As I think about it, there's one other, I'll mention that other piece in class on Thursday and Friday. So I hope you have a good Wednesday, and I'll see you later this week.